Hello, this is Special Equations lesson 4. In this, I will continue with more type of questions on special equation. Now, pause the video, try to solve this question yourself, as these kind of question I have solved in lesson 3. So, can I say 1 by x is equals to 1 by 6 minus 1 by 3y. This will be equals to, can I say that 1 by x, this will be equals to, if you take the LCM, this would be 6, can I say this is 6y, this is y, minus this is 2. So can I say x would be equals to 6y upon y minus 2. Now that was the first task. You have to separate variables x and y. Then now whatever there is number in the denominator, make that same number in the numerator. So can I say x is equals to 6 into y minus 2 plus 2 divided by y minus 2. You will get x is equals to 6 plus 12 upon y minus 2. That is the value of x that you will get. Now again, my y minus 2 must be divisible by 12. Can I say that y minus 2 must be a factor of 12? Now factor of 12 could be positive or negative factor. We have to consider both. Can I say that positive factors could be 1, 2, 3, 4, 6 and 12. These are positive factors. Same way minus 1, minus 2, minus 3, minus 4, minus 6 and minus 12. I will check which of them are valid options. Y minus 2 is 1, y is positive as well as x is positive. Same is true for all these values. So these will be 6 solutions that are definitely correct. What about this? Y minus 2 is minus 1. Y minus 2 is minus 1. So y would be plus 1, a valid positive integer, but x would come negative because x would become 6 minus 12 minus 6. This is not a valid. Minus 1, same way minus 2 and others will also not be valid. So total number of possible solutions are 6. Next question is 1 upon 2x minus 1 upon 3y. This is equals to 1 by 13. You need to find the positive integer solution. I am trying to teach you all the different kind of questions that can come in your exam. So first pause the video, try to solve yourself. First my task would be to separate the variables. This is 1 by 13 minus 1 by 3y. If you solve, this is equals to 39y. This would be 3y minus 13. So 1 upon 2x would be equals to 3y minus 13 upon 39y. Which means that 2x will be equals to 39y by 3y minus 13. That is the value of 2x. And x would be 39 by 2. Or you can say that 1 by 2, this is 39 y upon 3y minus 13. Now this is important how to solve it further. So what I will do, I will whatever there in the denominator, this 3y minus 13, I will make that number in the numerator. 3y minus 13, I will make that number in the numerator. So how I will do? First I will take 13 common. So can I say this is 13 by 2. This is 3y is left. 3y by 3y minus 13. This is a very important task, how to simplify. Again, can I say that this is 13 by 2. What I will do, whatever there in the denominator, I will make that in the numerator. 3y minus 13 plus 13 by 3y minus 13. So this will be equals to 13 by 2 into, this would be 3, this would be 1. If you make this bracket, you divide, this will become 1 plus 13 upon 3y minus 13. If you solve it further, this will become 13 by 2 plus 169 by 2 into 3y minus 13. That will be the value of x. X is equals to 13 by 2 plus 169 by 2, this into bracket 3y minus 13. Now better if you take half common both sides. So this will be equals to half is equal to 13 plus 169 by 3y minus 13. Now that is the value of x that you are getting. So I am writing in the, now that is the value of x that you are getting. I have made a blue circle. Now we know that x and y are positive integer. So first of all, my 3y minus 13, this 3y minus 13 must be completely divisible by 169, or you can say that 3y minus 13 must be a factor of this of 3y minus 13 must be a factor of 169. Now 169, this is equals to 13 square. So how many factors have it? Will have only three factors, that is 1, 13, 169, and also we will check for the negative factors -1, -13, -169. Condition is that both x and y must be positive integers. Now if 3y minus 13 is 1, 3y minus 13 is 1, then 3y would be minus 14 and y will be fraction. This is not a valid answer. I will first checking for y, then I will check for x. 3y minus 13, this is 1, although this will be divisible by 169, but y will not come integer because 3y minus 13 is 1, then 3y would be minus 40, which is not valid. Now 3y minus 13 is equals to 13, then 3y would be your 26, again not valid. Now 3y minus 13 is 169, then 3y would be 169 plus 13, that would make this is equals to 182. Now 182 again is not a multiple of 3 because 3y minus 13, as you can check, this is equals to 169, then 3y would be 169 plus 13, that is 182. Again this is not divisible by 3, so this is not also valid, not a valid value. Minus 1, look at this, 3y minus 13 is minus 1. This will make us the positive integer value of y. Can I say 3y minus 13 minus 1, then 3y would be 12, y would be 4, valid. Check the x. When 3y minus 13 is minus 1, then x would be negative. Now if you check, this is minus 1, this will make x as negative. Again this is not a valid answer. 3y minus 13 is minus 13, this will make y 0, again not valid. 3y minus 13 minus 169, this will again make the value of y negative. So no solution exists for this expression. No positive integer solution exists. If the question could be for integers, then we can check which of the values that will satisfy, but the basic concept will remain same. So in this question the answer would be positive integral solution is 0. No solution exists. Next question is a bit different one. A square minus b square, this is equals to 72. You need to find the positive integer solutions, pairs. How many pairs of a and b are possible? Now for all such question you have to take, this is a square minus b square is a plus b into a minus b, this is equals to 72. Now how I will understand? I will understand this question in a way that the product of two positive numbers is 72. A plus b is large number, a minus b is the smaller one. Now what's the core concept in this question is that a plus b as well as a minus b will of same parity. If a plus b, parity means if a plus b is even, then a minus b will always be even. And same is true if a plus b is odd. If a plus b is odd, then a minus b is always odd, always. So both a plus b as well as a minus b have same parity. Either the both are even or both are odd. Condition is that both are positive integers. If a and b are positive integer, that is what we need. We need positive integer solution. If a and b are positive integer, very important thing, if a plus b is even, a minus b is always even. And if a plus b is odd, a minus b is also odd. That is called as same parity. You can check. 7 plus 3 even, 7 minus 3 is also even. 8 plus 4 even, 8 minus 4 is also even. Same way if a plus b is odd, if I say that 8 plus 5 is odd, 8 minus 5 is also odd. And if you take that 4 plus 7, if you take 4 plus 7, this is odd, 4 minus 7 is also odd. So very important, a plus b as well as a minus b both have the same parity. Now what we will do, we will make 72 as a product of two numbers. How this is possible? A plus b will be larger number. This is 72 into 1. This is 2 into 36, 3 into 24, 4 into 18, 6 into 12, and 8 into 9. This is only 5. This is how many ways? 6 ways we can write 72 as a product of two numbers. Now I will check which of them are valid. I know that both will have same parity. This will not be valid because a plus b is even, a minus b is odd. Otherwise, if you are not able to understand the logic, first of all you must understand the logic. If in any case you find it that it's a bit difficult to understand how I will remember in exam, you can also check that this is not a valid solution, because if a plus b is 72 even, a minus b is 1, if you add you will get 2a is equals to 73. A is in a fraction. That is what we don't need. So if we need integer, both must be even or both must be odd. This is valid 36 and 2. If a plus b is even, a minus b is also even. This is a valid solution. This is not a valid solution. This is valid solution. This is valid. This is not a valid. So how many possible pairs are exist? This is 1. This is 2. This is 3. So answer is 3 possible pair exists. Now if you solve this, this will be valid. A plus b is 36. A minus b is 2. I am just solving here. On the right hand side, a plus b is 36. A minus b is 2. If you add this, 2a is equals to 38. A is equals to 19. A is 19 and then b would be equals to 17. So 19 plus 17 is your 36. 19 minus 17 is 2. And this is valid. 19 square minus 17 square, this will give you 72. So 3 possible solutions are there. So answer will be positive integer. How many solutions are there? 3 possible solutions are there. Question number 4 is a square minus b square is equals to 105. Now pause the video, try to solve yourself. You need to find the positive integer solution. How many positive integer solutions we'll have for a and b? Again, this is, can I say that this is a plus b into a minus b. This is equals to 105. Now both must have same parity. That is what I need. Both must have same parity. So how can I write 105? 105 into 1. This is 3 into 3 3s are 9. 3 5 30. This is 7 into 15. Only 3 possible solutions I have for this. Also would be 5 into 21. 5 2s are, yes, 5 into 21. These are the valid 4 solutions. A plus b will be larger. Now both must have same parity. Both are odd, both are odd, both are odd, both are odd. So there are 4 valid solutions. So answer is 4. 4 positive integer solutions are there for a square minus b square equals to 105. Now question number 5, x square minus 9y square, this is equals to 240. We need to find the positive integer solution. Can I say this is x plus 3y into x minus 3y, this is equals to 240. Now 240 is a product of two numbers. How can we write? Can I say this is 240 into 1 and this is 2 into 120. This you must be very fast in calculating. 3 into, this is 80, this is 4 into 60, 5 into 5 4s are 20, 48, 6 into 40, then 8 into 30, then this is not divisible 9, 10 into 24. Also I am writing on the right hand side this is x plus 3y into x minus 3y, this must be equals to 240. So 10 and 24, then it will be 12 into 20, then 13 14 not divisible, 15 it would be divisible, 15 ones are 15, left is 9, 15 16, that is 240, and that will be the last solution because x plus 3y would be larger. Now let's assume this is equals to a and this is equals to b. A into b is 240. Now if you take x plus 3y, this I have assumed this equals to a, x minus 3y, this is equals to b. Now if you add these two equations, this you get 2x is equals to a plus b. Now x must be a positive integer, so x is a plus b by 2. Can I say that x must be divisible by a plus b equals to 2? Now very important thing to have to understand that for x to be integer, for x to be positive integer, a plus b must be divisible by 2. a plus b must be divisible by 2. Also see the division part, subtraction part. If you subtract them, x plus 3y is equals to a, x minus 3y this is equals to b. If you subtract this, 6y this is a minus b. So y is equals to a minus b by 6. It means that y will be positive integers when a minus b, difference is a multiple of 6. So a minus b, the difference must be a multiple of 6, then only your y will be positive integer, and the addition must be divisible by 2, then only your x is a positive integer. Addition a plus b must be divisible by 2, then only you will get x as an integer. Same way, the difference a minus b must be a multiple of 6, then only your y will be an integer. Now check this first thing, a plus b. You can see that a plus b 2 is 241, not divisible by 2. Will not take this case. Here 120 into 2, 120 plus 2. If you add this 122, this is divisible by 2. So addition is valid. So x value will be integer, but difference a minus b should be divisible by 6. Look at this difference, a 120 minus 2. This is 118. Now check this 118. Is it divisible by 6? So 6 ones are 6. This is not divisible by 6. This is also a not valid solution. 80 and 3 again you add, not divisible by 2, not valid. 60 and 4. If you add this is divisible by 2, 64. But if you take the difference, 60 minus 4, 56. This is not divisible by 6. So this is not a valid solution. 48 into 5 not valid solution. 40 into 6. Again difference is not a multiple of 6. 30 and 8 not valid solution. 24 and 10 again not a valid solution. No valid solution exists for this. So x square minus 9y square 240, no solution exists of such that x and y are positive integers. So answer is no solution. So that was all about this lesson. Thank you.